Welcome to the hydraulic press channel. Today we are going to find out what is the best material for your rings. And we have here a nice collection of square-made rings. They are CNC machined from different materials. You can see all the materials here on the table that we are going to test. They also have gold, but it's really soft and expensive. So we are not going to test that today. And all of square-made rings are exactly the same shape and size. Of course you get like different sizes, but if you pick your finger size and order like 5 different rings, all the dimensions are exactly the same. I even checked that with the micrometer and they are really close, like 1/100th of a millimeter difference. So this is going to be really fair test to test different materials. And I got the square-made rings for free for this video. They also sent a discount code if you are interested on the rings. They said that it's really rare for them to give any discounts. So be sure to use code hydraulic at the checkout and you are going to get 15% off. There's also a link down in the description that you can use. And I'm going to test these in 2 different ways. I think first we are going to test them like this, like standing up and then laying down. And under the thing I have my 240 ton force sensor. It's probably not optimal for the rings because the resolution is 50 kilos, but at least laying flat like this we are going to definitely see some differences. And it's also interesting to see how different materials deform under the pressure. I'm going to use my super fancy macro lens and really nice Sony FX3 cameras, so you are going to see everything in great detail. Yeah, I think we are ready for the first round. Okay, here we go. First one, cast iron. And I think this is going to crack. Okay. Okay, that was surprisingly strong and flexible. I think it was like around 50 to 100 kilos when it started to go. And here you can see my machining surface quality from my tools transferred to the ring compared to the original from the ring. There's some difference. But those are straight from the lathe. They use some kind of diamond tools and probably really small feed to get like that nice surface quality without any polishing. Yeah, but then the next one. Yeah, this is some kind of super fancy Damascus titanium. They say Mokum. How you should like pronounce that, I have no idea, but that it says. And I assume that it's going to be stronger than the cast iron. Actually, maybe a bit less. Yeah, definitely a bit less. No, pretty much the same. I think that's enough. Yeah, titanium and steel or iron, they are usually on around the same ballpark. At least with the cubes that I have tested. Yeah, this looks super fancy. Slightly cracked there. Then we have one of the most interesting rings. This is tungsten or wolfram. And what is interesting about this is the fact that it's not tungsten carbide. It's their own material blend. There is tungsten and small amount of copper, and it shouldn't crack as the tungsten carbide bits tend to do. So interesting to see how it goes, and I assume that this is going to be stronger. Okay, it's like, I'm going to stop here, I want to see what happened. It's still more brittle than titanium, clearly. but it didn't like explode into a million pieces, which is also pretty typical with these. There's like clean cracks. It also bent quite much, but definitely not the strongest ring on this orientation. And then we have silver, pretty fancy. Yeah, this is the weakest so far. It's also quite like stretchy or malleable. It didn't crack at all. Then we have zirconium. Oh, okay, that was quite brittle. And it's interesting that the Wikipedia said that it's soft metal, but then it did that. Maybe it can be like soft and brittle at the same time. But the next one definitely ain't brittle, because we are going to go with the copper. Okay, how is our coin doing? Pretty nicely. It turned out really, really thin actually. Then, regular titanium. Okay, and then we have black zirconium. I'm not sure, is it just the surface or is it the material completely true black? Okay, there is some kind of difference because this didn't like shoot out from the machine. Then we have aluminium. Also pretty soft. And then the last one. This is stainless steel. Oh, that was pretty fast. Yeah, one of the hardest. Yeah, and now I'm going to fix my upper tool, and then we are going to put the ring sling down, and I think that's going to tell some like differences on how strong they are. I think this round was mainly how they are going to break, not about the strength so much, because standing up they are pretty weak compared to our resolution of the scale. Yeah, let's see how it goes. First one is the cast iron. Okay, there was thump sound, and I think I'm going to put 20 tons on each. One. Yeah, about 20. It's not very precise. Okay, I machined the tool again flat, and I'm going to skip the 20 tons part. I'm going to go as long as it takes to break them, and then I'm going to check the tool Okay, and here are the results in nice table. It was really hard to estimate when the rings gave up because they're so small and the table flexes quite much. But these are my estimations, and there's clearly like harder materials and a bit softer, but even like 200 kilos on top of your fingers, bad news, so I think these won't matter that much, but still interesting. And thanks for SquareMade for sending the rings to be tested. Link to their website is down below, go check it out, more machining videos there. Yeah, and that is all for today. Thank you for watching and have a nice day.